We're going to keep the show moving a little bit here, just to kind of step things up a little bit. I can read these better when I put on my glasses, I realized. So, our next presenter says he's a rocket scientist from Georgia Tech, a user experience designer from Wolfram Research, a photographer for everyday life, and as a driver, racked up 20K miles on a road last year to win somebody's heart. Ladies and gentlemen, Brian Lee.
Thank you for that, Michael. Just wanted to, by a show of hands, how many of you have already booked flights for Memorial Day or something like that for this year? Okay. Well, what I wanted to do today is kind of provide you a glimpse of what goes beyond the terminal gate. And for many of us, when we start thinking about air travel, we kind of start off from the online experience of searching for the flights that match our dates and comparing prices on Kayak or Priceline and booking the tickets. And images of aircraft taking off and us enjoying our time at our destinations come to our mind. But then we are also reminded of times like this. Flight delays and cancellations, searching for power outlets at the terminals, luggage not fitting in the compartment, wondering why the aircraft is not leaving from the gate and just sitting there waiting. With all of the things that are going on, it's easy for all the logistical and technical efforts to go unnoticed. So for my graduate program at Georgia Tech in Atlanta, I had the opportunity to explore the vast and complex world of air travel and air traffic control. Our Cognitive Engineering Center was involved in anything from the flight deck systems to the ones on the ground for flight planning and aircraft guidance. And we were not only interested in the technologies that improved air safety and optimizing flight paths, but also the impact on the acceptance by people who use them. And simulation and testing was very crucial and a big component of our research. Here, I'm demonstrating to a dozen undergrad students of a simulator of a radar display that air traffic controllers use to guide aircraft through their airspace. I also worked on a design of additional tools for air traffic controllers that address specific problems. Now, in this scenario, another lab at Georgia Tech had developed an algorithm to calculate and recommend new aircraft routes for aircraft that were in danger of being too close. So I worked on the interface concepts to help translate that information for the controllers. Yep, and that's our national airspace system. It's a complex network of systems dependent on each other that aim to operate at the level of perfection as the New York Philharmonic Orchestra. But rest assured, it has a ton of redundancies to keep you safe in the air. So what makes up the National Airspace System? It consists of 19,000 airports and 600 air traffic control facilities stationed by over 14,000 controllers that help 50,000 flights a day to get from gate to gate. And that number is growing every day. And there are also any number of general aviation aircraft that include corporate jets, charter flights, and private aircraft. Now, you may have seen some of these peculiar-looking structures like these by the highway or county roads. VORs, or very high-frequency omnidirectional range stations, are part of the extensive radar systems that cover a good part of the US airspace. The radio waves transmitted are received by the aircraft to help pilots determine their position. The FAA divides the continental US airspace into 20 Air Route Traffic Control Centers, or ARTCCs, such as ZAU, which is the one controlled by the Chicago Center. Those centers are further divided into smaller sections that's more manageable for individual controllers. Anchorage and Honolulu makes up the two more ARTCCs. So for example, if you wanted to fly from the Twin Cities in Minnesota to Chicago O'Hare, it would begin from the Minneapolis Center to the Chicago airspace before they begin their landing. As it crosses the ARTCC boundary, roughly around Madison, the responsibility of the aircraft guidance and communication is handed off to the next sector. Inside the air facilities, controllers are working around the clock to keep aircraft on track with their planned routes and monitoring unauthorized aircraft in the airspace and redirecting aircraft from harmful areas such as thunderclouds. The top photos is from the half century ago, and below is the more of a modern one, and you can see there's not much difference. When it comes to separation, the job of the controller is to keep them separated And generally speaking, for most jets in cruise flight, they are to be 1,000 feet away in vertical and 5 nautical miles laterally. And for each altitude ranges and whether the aircraft is near an airport, rules can change, but seems simple, right? But not so much. This is one of the views that they have to deal with. Each little grouping of the yellow text represents an aircraft, and depending on the situation, they could overlay weather information, location of VORs, airports, and other things of interest. So let's take a look at what the text labels can say. Here, the first line indicates that it is an American Airlines Flight 925. The second line states that it is climbing to flight level 370 from 257. And from the third line, controllers know that its speed is 383 knots, and it is a Boeing 737 aircraft. The green line shows the direction. Now, several slides back, I mentioned that air travel is projected to grow, although maybe not to this level. However, by some calculations, air traffic will nearly double to 78 million flights per year by 2025. At this rate, our current system cannot support such demand. One of the biggest concerns that we have is the impact on our environment. Aircraft burn huge amount of fuel around the airport airspace as they climb and descend. Places like the Northeast Corridor that contain Boston, New York, Washington, D.C. could be hit hard if nothing is done. But fortunately, the FAA is doing something. Now, through a program called NextGen, they are currently overhauling the system with new hardware, improved procedures and flight paths, and encouraging fuel-efficient aircraft. Airlines love this because they are able to save fuel and time. And of course, safety will remain as number one. So inspired by the many changes that are going on by the FAA, my grad school thesis focused on different ways to map out our airspace, one of which was using relative distances to determine the position of an aircraft instead of using VORs and fixed waypoints, with the hope of reducing the cognitive workload of controllers. Because I've been convinced that the air traffic controllers indeed have one of the most stressful jobs in the world. But looking at the safety of our air travel, they sure are doing one heck of a job so that passengers have one less thing to worry about. It sure made me more appreciative of all the work that's been going around it. Thank you so much for listening and have a great evening.